Welcome back. Today we're talking about factoring polynomials with using greatest common factor. Let's go ahead and take a look at some vocabulary. So we have a few vocabulary terms to know. First, a factor. A factor is a number when multiplied with another produces a given number or expression. So for example, negative 9 times 5 equals 45. Not negative 9, regular 9. The factors are 9 and 5. Steps for simplifying are we're going to find the greatest common factor in our polynomial and we're going to remove it using division. So let's go ahead and take a look at that with example A. All right, here we are with example A where we're going to factor our expression. Now we're going to use our greatest common factor. So we're going to look for our GCF, the biggest number and variable that we can pull out of all of our current terms. So I've got 16x to the third and negative 24x. So I'm first going to look at my numbers and I can see that I've got 16 and 24. So I'm going to look for the biggest number that I can pull out of both 16 and 24, which is going to be 8. So I'm going to be able to pull 8 out looking at my numbers. I'm now going to look at my variables to see what I can pull out, and I can see that they both have an x. Now I can't pull out x squared or x to the third because negative 24 only has one x, so I can only pull out one x. So what I can pull out is 8x. So that's the thing that I can pull out as my greatest common factor. So when I do that, when I pull out my 8x, the only thing that's left I'm going to do by division. So 16 divided by 8 is going to give me 2. So I'm going to left with 2 there. Since I removed one of my x's, I'm left with only x squared now. For my 24, or my negative 24 there, I'm going to carry my negative sign. I can pull out that 8. 24 divided by 8 is 3. And since I took out the x, it no longer has an x. So the only thing that's left is 8x, parentheses, 2x squared, minus 3. Now let's take a look at the next example. So here in example B, again, I'm going to look for my greatest common factor, so things that I can pull out that are both my number and my variable. So I'm going to start with my numbers. So I've got 20, negative 15, and 30. The number that's the biggest that I can pull out of the three of those is going to be a 5. So that's my number. And now I'm going to look at the variables, and this is where it gets tricky. So I've got x squared, x, but plus 30y doesn't have an x. So I can't pull x out because it doesn't have one. So now I can check for my next variable, which is y. So I've got a y in my first term, a y in my second term, and a y in my third term, so I can pull out a y. So my greatest common factor in this case is 5y, because I can pull out both the 5 and the y. All right, so now I'm going to do that, and I'm going to see what I have left. So when I do 20 divided by 5, that's going to leave me with 4. And then I'm going to have x squared, because I didn't touch the x's, but I did take away one of my y's, so now I have y to the third. When I go to my next term, I've got negative 15 divided by 5, which is going to leave me with negative 3. Again, I didn't touch the x's, so it's going to stay x, but I did take away one of my y's, so now that's just regular y. When I do positive 30 divided by 5, that's going to leave me with just positive 6. And because I took away its y, it doesn't have any more, so I'm done there as well. Now let's take a look at the next example. So here in example C, again, I'm going to be looking for my greatest common factor, but I have a little bit of a trick here because this one has a negative as my leading coefficient. And whenever I have a negative in my leading coefficient, I'm going to make sure that I remove that negative when I'm looking for my greatest common factor. So if I'm looking at negative 5 and 35, the biggest number that I can pull away is 5, but because I want to make sure I want to take care of that negative, I'm going to bring that negative with me, which is going to affect things later, but let's make sure that we've got it now. We're also going to pull out some variables in this case, so they both have an x, they both have a y, but the 35 only has one of each, so x and y only one each for my greatest common factor. So now we're going to go ahead and write that down as our greatest common factor. So negative 5, x, y. And now we're going to see what we have left. So if I divide negative 5 by negative 5, that's going to leave me with just positive 1. Now we're going to not write 1 because we don't write coefficients of 1. But we're going to look for our x's now. I took away one of the x's, so that means there's still one left. There are 3 y's there. I took one away, so now I have y squared. Now, when we jump to our second term, we took away a negative 5. We divided 35 by negative 5. So when we do that, 35 divided by negative 5 is going to leave me with negative 7. And that's very important to notice that my sign has switched. Now I'm going to check I took away both that x and that y, so I'm done. Now you can always double check to make sure you worked by using distributive property to check, did this work? So if I multiply -5 in, I'll end up with -5 again, and the x and the y will become x squared and y to the third. And I can also check that with the other one, with -5 times -7 would give me positive 35. So you can double check your work and make sure that you're doing it right when you pull out that negative of your leading coefficient. Now let's go ahead and take a look at the last example. So here in example D, again, we're going to be looking for our greatest common factor. So we're going to be looking for both numbers and variables, but I've got that leading coefficient. That first coefficient is a negative, so I want to make sure that I have a negative number coming out. And then I'm going to look 2, 4, and 6. The biggest number that I can pull out of there is a 2. And then I'm going to look for my variables. In this case, I've got m squared that can come out because I've got m to the fourth, m to the third, m to the second. So I can pull out two m's there, m squared, because that's the greatest common factor out of all of them. So I'm going to pull out an m squared. All right, so now that I've got that, I know that negative 2m squared is going to be in the front. And I'm going to create some parentheses here to see what we still have left inside. So negative 2 divided by 2 is negative, or it's positive 1. We're not going to write that leading coefficient, but we're going to take out the m squared there. When we do that, we're going to be left with just m squared, because we took away 2 of the m's from the 4, so we've got 2 of them left, so we've got m squared. Now we'll go down to our next term there, where we're going to do negative 2 divided by positive 4, so we're taking that, and that's going to become a negative now. So we've got negative 2 there, and then we took away 2 of the m's, so we're left with just one m in the middle. And then we're going to go down to our third term, where we're going to do negative 6 divided by negative 2, which is going to leave me with just negative 3. And then we decided, okay, we took the 2 squared, so that's going to take away all of the m's. So the last thing we're going to be left with there is m squared minus 2m minus 3. And that brings us to the end of this problem. It also brings us to the end of this set of notes and this video. If you like this video, go ahead and say thumbs up. If you love this video, go ahead and say sub. And we will catch you in the next one.